Hey math kids, today we're going to talk about the sine rule. It's chapter 8, section D in your book. And the sine rule is sine A over A, sine B over B, and sine C over C. So all the things on the bottom are sides, and all the things on the top are angles. So capital A, capital B, capital C are angles. And once again, it's if we had something like this, A, B, C, this would be B, this would be A, this would be C, because they have to be opposite the thing that we named. And so let's go to example 5. It says, find the length of AC to 2 decimal places. Okay, so we have this diagram. This is 58. This is 39. And then we have A, B, C. And this is 12 centimeters. And we're trying to find AC, so I'm going to mark that with an X. Okay. So when we're using the sine rule, we want to group things that are opposite in the same sine expression. Now another, let's see, sine A over A, sine B over B, sine C over C. Now you only have to use 2, you don't have to use all 3 of these. Sometimes kids get confused with that. Why is there 3 written and we're only using 2? It's because it's all equal signs. So we want to make sure that what we're solving for is on top, and since this is just a ratio, we can actually also write this like this. And, whoops. I think it's easier to start with whichever version puts your variable on top. So since we're looking for a side, I'm going to use the yellow version of this. And I'm just going to put my side on top, and then the opposite angle, so sine 58. Then I'm going to put my other side on top, and then the opposite angle, sine 39. Now doing that makes the algebra easier. All we need to do is multiply both sides by sine 58, because it'll cancel here, sine 58. And then we just go to our calculator. We just have to plug that in. So 12 times sine 58 divided by sine 39. And make sure your calculator is in degrees, or else you won't get the same answer. And so our answer is 16.17 centimeters. Okay, let's move on to the next one. It's example 6. It says determine the size of ACB correct to 3 significant figures. Sig figs. There we go. Alright, so they have a triangle that looks like this. ACB, 15 centimeters right there. 37 degrees. 20 centimeters right there, and we're asked to find angle C. So that's our theta right there. Once again, we want to group things that are opposite, so I'm going to group those together, and I'm going to group these together. Now, because we are finding I'll just write it out like that. Since we're finding an angle, I'm going to use it with my signs on top, because I want the thing I'm solving for to be on top. It just makes the algebra easier. So I'm going to start with theta. So sine theta, and then the opposite side is 15. And then sine 37. That's a bad 7, but that's a 7. 37 over 20. Okay? So I only have to do a few things algebraically. So I'm going to multiply both sides by 15. And I get sine theta equals 15 sine 37 over 20. And then I do the inverse sine of that. So the inverse sine. So theta equals the inverse sine of 15 sine 37 over 20. Now, I'm not going to directly type it into my calculator like that. I'm going to show you how I do it so I don't get confused. So I'm actually just going to worry about the stuff that's inside of the inverse sine. So I'm just going to say 15 times sine 37, parenthesis, divided by 20. Hit enter. Then I'm going to go to second inverse sine. And I'm not going to type that in. I'm going to say last answer. So if you see the blue right here, it says answer. So you go second, hit that. So that's going to take my last answer. It's going to take all the way out, even past what it shows on the screen, plug it in, and then I hit enter. And I end with 26.8. That's my three significant figures, 1, 2, 3. And it was an angle measurement. So that angle is 26.8 degrees. My point isn't very dark. Okay. If you need additional help, come to Math Lab, but for now, calculator.